Okay, guys, in this video, we are going to take a look at how to find the direction in which the directional derivative of a given function at a given point is the largest. What does that mean, really? So think about walking on the mountain, hiking the mountain, right? So imagine you are on a mountain and you are standing somewhere and you are like, okay, I really want to exercise. Okay, I need to exercise. So find me a direction that's going to be as steep as possible, the steepest possible. And that would be where I'm going to go because I need to exercise, of course. So how do we do that? Well, here's how we do that. We're going to take this function, whatever it is, and we're going to find its gradient. And that vector will give you the direction of maximum rate. Like that would be the largest possible, or the steepest possible way to go. Why? Well, what is directional derivative? So directional derivative, let me just write down like how we find it. In a certain direction, so vector u, of function g at some point, so let's just say ab. Okay, so what's that equal to? So first we have to find the gradient. Then we have to plug in the points, so AB. Then we're going to dot it with the direction vector, dot product it, okay, with the U. And I'm assuming that U has unit length, okay? So maybe I should actually put a hat on it as opposed to an arrow, just to make sure that that's like a unit length. Okay, now the dot product has another formula. And I don't know if you remember that from our dot product days, but the way you do that is you take the magnitude of the first vector, which in this case is the gradient, multiplied by the magnitude of the second vector, multiplied by the cosine of the angle between them. Okay? But here is what I want you to notice. This right here is a magnitude of u. But remember, u has a hat, which means that the length of this is just 1. So this is 1. Okay, this is always going to be 1. And then the gradient is not going to change because that thing only depends on A and B. So you have to know where you are on the mountain. But the direction will be determined by the angle theta, right? Okay, so what is this angle theta? Well, the angle theta is between the gradient and that vector of direction, u, with the hat. Okay, that's what this angle is all about. So it's not the same thing as like the direction vector, the angle with the x-axis. That's not it. It's the angle between, maybe I should not call it theta, but whatever. It's the angle between the gradient and the direction vector. So we want this cosine theta to be as large as possible. Now, I hope you remember that cosine is like a wave, right, that changes between -1 and +1. What is the value of cosine that would be as large as possible? Well, that would be 1. When is cosine equal 1? Well, cosine of an angle equal 1. That's when this angle is 0 degrees, right? Or 0 radians, it doesn't matter, right? Because cosine of 0 is 1. So what we are saying is if the gradient and u have the same direction because the angle between them is 0, then this cosine is going to give you 1, right? So if they go in the same direction, cosine of the angle of 0 is going to be 1, and that's going to be as large as possible because, again, this does not change based on direction. Only this thing changes. And so when the vector u has the same direction as the gradient, the directional derivative will be as large as possible. And if we want the smallest direction, then it should be the opposite, because if the angle is like 180 degrees, then cosine would be -1, and that's going to be the smallest possible direction. Okay, so in a nutshell, what that means is the direction of the maximum increase is the direction of the gradient. All you need is find the gradient, and that is your answer. The gradient you seek. That's what Yoda said. Okay, let's go ahead and take the gradient. So I hope you agree that that's important. Okay, so what is g? G was 3x minus xy plus 4y squared. Okay, so let's highlight the terms that have x. So this term has x, this term has x. Okay, so let's take the derivative. 3 minus xy. So think of y as a number. So yx is derivative is y. Okay, the other one is going to go away. Now, let's only highlight the terms that have x. So, sorry, y. Yeah, so that's going to be what? Negative, so don't forget about the minus here. So with respect to y, this will be negative x plus 8y, right? Okay, so we got that. That's the gradient, we got it. Now we want to plug in the actual point to 3, negative 2, okay? We're gonna plug that into the gradient, and that would be the largest possible increase, cheapest possible. If you really want to exercise, you go in that direction. Okay, so we are plugging in point 3, negative 2. So 3 for x and negative 2 for y. So we're gonna get negative x is 3, plus 8y, y is negative 2. Okay, so looks to me like I got positive 5 and negative 3 minus 16, negative 19. Okay, so that would be like, oh, he wants i's and j's, doesn't it? Okay, fine. Okay, so that is the direction. So now, what is the maximum value of the directional derivative? Well, remember that when we were proving this, we said that the maximum will occur when the angle is 0, which means that this guy is going to be 1. So the maximum value is equal to the norm of the gradient, or the magnitude of the gradient vector. So if you want the maximum, you need to find the magnitude of this thing. How do you do that? Well, you're just going to go ahead and square each component. So 5 squared plus 19 squared, don't worry about the minus, it's gonna go away. I got 386, and then we take the square root. So let's enter that here, okay? And finally, what is the direction? So the direction is actually already, we know what it is, 5i minus 19j. That's the direction. But they want you to make it a unit vector. Why? Don't ask me. Maybe they just want one answer and they don't want a possibility of like a multiple being found incorrect. So that's kind of like, you don't have to do that because this is the direction. So you care about which direction, you don't care about the magnitude. Okay, fine, but we're gonna normalize it. So how do we do that? Well, we're gonna divide by the magnitude, which by the way, we already know is square root of 386. So that's just gonna be that. And that's it.